I consider it my duty to publish an ultimate video summating all the formulaic relationships I've used throughout the last 6 videos pertaining to electrochemistry, advanced electrochemistry if I may say so. So I'd like to just let you know that the first one is charge equals product of current and time. Charge equals the number of moles of electrons times the Faraday constant. Mass deposited equals Q over F times atomic mass of the metal times the oxidation number of the metal. So that'll be IT AR over ZF. Now this is mostly applicable to solid metals, not so much to gases, as research into question solution has shown. The other one was volume of gases, which was QOF times 12 over Z, which is IT12, and that's for room temperature, over ZF, the oxidation number, the valency of the non-metallic gas anion. The other one for STP is so that's the for room temperature, and that's for STP. Please take a screenshot if you may. Now this particular equation is a merger of this equation and the other one was and then there's another one called gas times STP or RTP, whilst the one that ought to be used is IT over the number of moles of electrons, that's F times STP or RTP. Now this is how you're supposed to calculate the volume of gas coming at an anode or a cathode, and when in trouble you'll have to use this formula and equate it. So you'll have to equate 1 and 2, and it'll be STP, as you know, is 22.4 moles per dm cubed, and room temperature is 24 dm per dm, 24 dm cubed. And so you'll have to do this. Now you'll have to then, you use the pressure and this and that now this is the moles of electrons of gas, and this will be the number of moles of electrons. Now if the number of moles of electrons in a gas is not available, then you'll have to use number of moles of electrons here as well. So this is how you combine these two equations. For the previous equation where you were supposed to find out the mass deposited, if the mass isn't available, then you'll have to do AR times number of moles equals I times T AR over F, and that way AR would get cancelled out, making your life easier, times Z. And so if you've got the number of moles for a particular metal, you'll just have to use this. You won't even need to convert it to mass. You'll just have to use this part and get your answer for, whatever the unknown you're looking for, whether it's time or current or oxidation number. And then later you can then convert the number of moles into mass if need be. So now I've finalized the kind, genre of the formula you'll be using. Now these two formulae, bear with me, the ones I've so the ones that were pertaining to IT over F times 12 over 1, 12 over the Z, 12 over Z, or 11.2 over Z. Okay, so now I want you to take a screenshot of this. Five, 4, 3, 2, 1. And so this concludes our affair for electrochemistry. I wanted to publish a final summation that would conclude our journey for electrochemistry and would make you confident in understanding the rationale behind all the formulae I used, and also give you a complete list of all the formulae that I've used over the past 50 questions. And I've solved a myriad of questions pertaining to all kinds of electrochemical situations, except for redox series. That is quite self-explanatory with the salt bridge, and I haven't come to it yet. So I hope you'll be able to remember, list, and reproduce them in exam and use them to your advantage. Please take a screenshot of these 2 pages, print them off, practice and memorize them, and familiarize yourself by looking at my videos, watching my videos repetitively, and pondering over the questions that were solved, so you may be able to benefit from it and pass your chemical calculational exams in flying colours. And I will take it from here. Now, if you have any comments or questions, please post them down below, and I'll try my best to answer it. However, I will be limited because it's not MATLAB, and I won't be able to use numerical script like LaTeX. It's not LaTeX, so if it's a numerical question, then you're better off doing it using Google. But if it's a theoretical, conceptual question, then I'll be able to handle it, because symbology is quite limited on an English keyboard, and YouTube does not integrate LaTeX fonts where you could use brackets and fractions and explain the whole sequence of a question by using arithmetic, mathematical, fractional symbology. So I'll take it from here. I hope you learned something today, and this concludes our journey on quantitative electrochemistry. And I doubt there are a lot of people on YouTube that have covered electrochemistry in this fashion. We all know about reactivity series, activity series, electrochemical series is pretty much the same. It's the same thing over and over again. but this part was neglected and needed brushing up, attention, and being shown light upon, and I think I've done my duty. And I've also shown how mistakes can occur, i.e. calculator mistakes, calculational mistakes, hyperinflation of the answers. And it was very important for me to demonstrate those skills so I could connect with my audience. And imperfection is a way to induce confidence. Human psyche is quite weird, and often mistakes, a demonstration of mistakes can help prevent them, which is why drills are performed prior. So thank you very much for your support. Please help yourself, and I'll take it from here. Thank you very much. Take care. Bye now.